Lighthouse Scientific Education presents a lecture in the Introduction to Chemistry series. Topic: Density, with problem solving. Material in this lecture builds upon the previous lectures, Math for Chemistry, and Fundamental Properties of Matter. Overview of the density lecture. We will begin with a definition of density, including compactness and the equation of density. Then on to using the equation for density, algebraically, and finding density from the density triangle, and finally, problem solving involving density. Density. Density is a measure of the compactness of a substance. Consider these two collections of equal number red spheres. The collection on the left is less compact than the collection on the right. The less compact collection is less dense. The more compact form is more dense. This is because density is a ratio of mass to volume. D for density equals mass divided by volume, or m over v for short. Let's consider each property in this equation. Mass first. Mass is almost always replaced with weight and determined using a balance. The unit for weights are given usually in grams or milligrams. And then there's volume. The volume of a liquid is easy to find. Every chemistry lab has graduated cylinders for measuring volumes with units of milliliters or liters. But volume of a solid is generally harder to find. Solids are either measured with a ruler if possible, or their volume is found by displacement in a liquid, much like measuring the rise in the water in a bathtub that accompanies a person getting in. Getting volume by measurement and displacement is covered in detail in the Density in the Lab lecture that follows this one. We can combine these collections of spheres and the equation of density equals mass over volume to give a greater understanding of density. To begin, the collection on the left, which we will call group 1, and the collection on the right, which we will call group 2, have equal numbers of spheres and therefore have equivalent or equal masses. M of group 1 equals M of group 2. Note the subscript designations 1 and 2. We can draw a box that contains all the spheres on the left-hand side. We will call that volume of that box volume 1. We can do the same thing to the collection on the right and call that volume volume 2. Volume 1 is greater than volume 2. It takes a bigger box to contain the less compact collection of spheres. Dividing mass 1 by volume 1 gives density for group 1. Dividing mass 2 by volume 2 gives the density for group 2. Since the masses are the same, these two densities will only differ in their volumes. Volume is in the denominator of this equation, which means the larger the volume, the smaller the density fraction. Therefore, density 1 is less than density 2. Density has two components, and we will consider them both when determining a density. Here's a list of elements and their densities. The mass and the density is given in grams, and the volume can have units of liters or cubic centimeters. It's handy to keep in mind that the relationship that says 1 mil is equal to 1 cubic centimeter. A cubic centimeter can be visualized as a cube whose length, width, and height are all 1 centimeter. Returning to the table and looking at the element helium, we see that it is one of the least dense elements. Tin, which is a metal, is much denser. Gold, which is one of the most valuable elements, is also one of the densest. It has a density of 19.32 grams per cubic centimeter. Compare that to tin's 7.31. The bigger the number, the denser the substance. Before we move on to solving density problems, it is worthwhile to review the algebra that often accompanies density problems. Density is a 3-variable equation. Density homework problems give values for 2 of the 3 variables and ask you to solve for the third. As covered in the Math for Chemistry lectures, Before entering the values for a problem into an equation, it is best to solve that equation algebraically for the unknown variable. That is, isolate the variable of interest by itself on one side of the equation sign. For demonstration purposes, we will say that our homework problem wants us to solve for the volume, B. It is currently in the denominator, and it will need to be alone in the numerator for it to be considered isolated. We can get the B into the numerator by cross multiplying. Cross means across the equal sign. To make it easier to follow, we can turn D into a fraction by dividing it by 1. Cross multiplying is taking the numerator of the first fraction, D, times the denominator of the second fraction, V, and making that equal to the denominator of the first fraction, 1, times the numerator of the second, M. V times D equals M times 1, and N times 1 equals M. To isolate V, we need to turn the D into a 1 by dividing both sides by D. D over D is 1, and V times 1 is V. V equals M divided by D. This basic level of algebra makes the study of chemistry much easier, and it behooves the student to master it. There is another way of handling these three variable equations. It is called the DMV Triangle, and it nicely lends itself to notes and cheat sheets for testing. It is used to isolate each of the variables in the density equation, and with a little practice, it is very easy to use. It can also be used with other three variable equations, such as velocity equals distance over time. Let's take a closer look. Begin by writing in the variables as follows: D, M, V. M over D, V. Next, cover the variable to be isolated. Start the equation with that covered variable. We can use D as an example of the variable of interest. That gives us density equals, step 2 is to write out the other two variables. To do this, we're going to need to find the mathematical operation between the two uncovered variables. We will use division if one of the variables is on top of the other, and multiplication or times if they are next to each other. Here, M is on top of V, so we are going to divide. Now we write out the uncovered variables with the divide operator. M divided by V. Density equals mass divided by volume. That's the definition of density. Okay, let's try another variable. Step 2, cover. And this time we'll cover M. Start the equation with mass equals. Step 3, write out the other two variables. D, and since they are next to each other, times V. Mass equals density times volume. We should also solve for volume. Step 2, write the equation, volume equals. Step 3, write out the other two variables, M, and since it's over D, divided by D. Volume equals mass over density. Now we're ready for some density problems. As stated earlier, density problems give values for two of the variables and ask to solve for the third. We will use the basic problem-solving structure to address these problems. To find the solution of a problem, first identify the known and unknown variables. Read the question carefully and take the time to identify and write out the numerical information from the problem. This is called the setup. This is also where you decide what the question wants as an answer. Generally, there will be a variable of unknown value. Second, find and then solve the relationship or equation algebraically. That is, find an equation that relates the known values in the setup with the variable of unknown value. Solving algebraically means that we have a version of that equation with the unknown variable isolated on one side of the equation and all the other terms on the other side. Then we input known values and solve with our calculator. Try not to input values before you have isolated the variable of unknown value. This helps reduce confusion and math errors. Let's put what we have covered to work. We'll solve one problem for each of the three variables in the density equation. Our first problem. The density of regular unleaded gas is 0.756 kilograms per liter. How many kilograms of gas does it take to fill a 25-liter tank? We will use the basic problem-solving structure to address the problem. First step is to identify the known and unknown variables. We will put these under the heading Setup. Starting with mass. Do we know the mass in this problem? No, we don't. Mass is an unknown. Do we know volume? Yes, volume is given as 25 liters. Do we know density? Yes, it is given as 0.756 kilograms per liter. So now we've completed step 1. Step 2, find and solve the relationship or equation algebraically. Do we know a relationship between the known values of density and volume and the unknown value of mass? Yes, the definition of density. Is it solved for the unknown variable mass? No. Here we could do the algebra, cross multiply, or use the DMV triangle to get mass equals density times volume. Step 3, input known values and solve. Mass equals density, 0.56 kilograms per liter, times volume, 25 liters. Note that there are units of liters in the denominator of density and the numerator of volume. They cancel out. Doing the math gives us 18.9 kilograms. So 25 liters of gas weighs 18.9 kilograms. That's what density gives us. Density allows us to move between weight and volume of a substance. Density problem 2. A 4.56 kilogram sample of an unknown substance is found to have a volume of 450.0 cubic centimeters. Find its density in grams per cubic centimeter. We begin with the setup. Step 1. Identify the known and unknown variables. Does the problem give us mass? Yes, it does. Mass is equal to 4.56 kilograms. Does the problem give us volume? Yes. Volume is 450 cubic centimeters. Remember, a cubic centimeter is the same as a milliliter. Does it give us density? No, it doesn't. We are asked to solve for density. It is our unknown variable. And that completes step 1. Step 2. Find and solve the relationship or equation that relates the known variables in the setup with the unknown and solve the expression algebraically. That relationship is the definition of density, D equals m over v. Fortunately, the expression is already solved for D, so we are done with step 2. Now we move on to the last step, which is to input known values from the setup and solve. Density, or D, equals mass, 4.56 kilograms, over volume, 450 cubic centimeters. And that solves to 0.0101 kilograms per cubic centimeter. Are we done? No. Look back at the question. It wants an answer in grams per cubic centimeter, and we have kilograms per cubic centimeter. We're going to have to convert the kilograms to grams. We're going to have to do a conversion. Is there a unit factor or a conversion factor which converts kilograms to grams? Yes. 1,000 grams equals 1 kilogram, and if we set up the unit factor like this, the kilogram units cancel out, leaving mass units of grams. If we do the math, we have the density of our unknown as 10.1 grams per cubic centimeter. Our final problem is The only pure metal to be a liquid at room temperature is mercury, with a density of 13.53 grams per cubic centimeter. It is much heavier than water, which is only about 1 gram per cubic centimeter. What is the volume of 1.00 grams of mercury? We begin with the setup, identifying known and unknown variables from the problem. Mass is a known in this problem. It is 1.00 grams. Volume is not known. It is what we are trying to find. Density is known. It is given as 13.53 grams per cubic centimeter. That completes step 1. Step 2. Find and solve the equation that relates the unknown and the known quantities in the setup, and then solve that expression algebraically. That relationship is the definition of density, just as it was in the previous 2 problems. D equals m over v. Here's a hint. When searching for an appropriate equation, it is often beneficial to look among the equations listed at the end of the chapter in which the question is found. If the problem comes up on an exam, the equation is probably among the list of equations provided for, or hopefully in the notes you prepared for the exam. Getting back to the problem, note that the equation is not solved for volume. This means we need to do the algebra or use the DMV triangle to get volume equals mass divided by density. It's time to finish up by putting the known values from the setup into the equation. Volume equals mass, 1.00 grams, divided by density, 13.53 grams per cubic centimeter. The math is straightforward. It's a straightforward division problem. It comes to 0.0739. What is more complicated are the units. We know that for volume, we need to end up with volume units. That's cubic centimeters. Since this is the first time that we've come across a unit type that has a fraction in the denominator, we will explore how units cancel out in a call-out. Here we have just the units. In the numerator, we have the grams for mass, and in the denominator, we have the fraction grams over cubic centimeters from density. When we realize that we are really just dealing with division of fractions, we can employ the fraction division rule that says flip the second or bottom fraction and multiply. Flipping grams per cubic centimeter gives cubic centimeters per gram. Note that the grams cancel out, leaving just cubic centimeters. So, when there's a fraction of units in the denominator, and it doesn't matter what the units are, flip them and bring them to the top and multiply. Our final answer is therefore a volume of 0.0739 cubic centimeters. 3 problems, 3 different solution types, each was solved using the same logical problem-solving procedure. We will attack many of the chemistry problems to come with this same basic approach. We have not, however, addressed all the different types of density problems. The density problem solving covered in this lecture will probably handle the majority of homework problems. Problems associated with determining densities in the lab, that is, using measurements, are covered in the Density in the Lab lecture. These include density using volume determined by a ruler and an equation, density using volume determined by displacement, and density from the slope of a line through measurements plotted as volume versus mass. If you have a density lab associated with your course, be sure to review this lecture. If you come across homework problems that have measurements or data values, you might also give that lecture a viewing, or at least part of it. Recapping the lecture. Density is a measure of the compactness of a substance. Density is a ratio of mass to volume. Weight is usually substituted for mass. Volume is usually measured, graduated cylinder, ruler, displacement. Density homework problems give you values for 2 of the variables and ask to solve for the third. The solution to density homework problems is found by identifying the known and unknown variables, finding and solving the equation algebraically that relates known values from the setup with the unknown value, input known values, and solve. And that completes our lecture. Head over to the concept and definition for this lecture and practice what you've seen.